When we think about the sources of spatial heterogeneity in ecosystems, it's important to understand that the sources of heterogeneity interact and can't be considered independent of one another. For example, parts of the landscape differ in their susceptibility to disturbance. When I was running a class out in the field in northern Minnesota, one way to start to think about how fire moved across the landscape was to set up a miniature landscape and then burn it. So essentially what the students ended up doing was finding a pile of dirt and then putting different fuels into that matrix. And then they just set it on fire. And one of the things that we could see relatively quickly is how fast fire moves uphill, but how slowly it moves downhill. In addition, you can think a little bit about how there's differences in fuels that exist on the landscape and how fire is going to interact with those differences in fuels. Greener, wetter vegetation is a lot less likely to burn than drier vegetation. So that was just an exercise that gets at the idea of how heterogeneity at the landscape interacts with disturbances, for example. But when we actually get to large-scale landscapes, those same general principles hold. The susceptibility of different portions of the landscape to fire are not constant, and there's some landscape level patterns of fire that exist because of topography, for example. So the pattern that we're going to see of disturbances on the landscape and the spatial heterogeneity that exists, some of that heterogeneity is going to be stochastic and due to just long distance dispersal of flames and embers. But there's also interactions between the arrangement of different components on a landscape and how the fire interacts with that. Another example is thinking about forests and root pathogens. Here on the x-axis, we have a spatial gradient essentially that shows a mature forest that is hit by a root pathogen and then forest recovery. And essentially this occurs as a wave as that pathogen disperses through the landscape. So this had been hit by the pathogen a while ago and then closer and closer in time up into the edge of the mature forest. For these different patterns of disturbance, we're going to have different patterns of nitrogen availability, just like you'd expect, with the most recently disturbed areas having the highest available nitrogen concentrations within the soils. So this is a pattern where we can see nitrogen mineralization varying across the landscape, and that's going to be dependent on the patterns of disturbance from pathogens. Interactions among processes that are controlled at different scales lead to nonlinear and sometimes catastrophic consequences. So this is another situation where scaling becomes important and thinking about some of the processes that exist on larger spatial scales. This figure represents cross-scale interactions that are influencing the nonlinear spread of disturbance across the landscape. So these disturbances, you could have fire or drought or disease, and they're controlled by different processes at different scales. So thinking about fire at a small scale is going to be a lot different than at a large scale. So once a fire starts, they're spread within there, but then you're going to generate new patches. And then often those patches will coalesce and generate even different dynamics for fire over larger timescales. So we have, in addition, feedbacks that occur across those scales that are going to interact and generate new patches, for example, too. The process is also associated with thresholds, and it's important to note that as we go across time and look at the spatial extent, that there's going to be thresholds where new sets of processes and new sets of dynamics become important. If we get positive feedbacks or amplifying feedbacks, that's going to generate an even greater spatial extent and an increase in the rate of spread of that disturbance. So we can have positive and negative feedbacks that exist at a variety of scales too. If you look on the landscape, this is essentially what some of the patterns that you could see, where you could have initiation of a small patch and probably a ground fire that happened here that killed plants, but it never really increased to burn into a large area. And we're going to have different dynamics when you get into these large areas that burn, and they're going to send embers and flames over larger scales. The heat that's generated from a fire in a relatively small fire isn't necessarily going to dry out local areas and the areas adjacent to that and increase the probability of fire. But once areas become large and there's a large area that's being burned, there's a lot of heat that's produced, and that's going to send heat outwards and make it more likely for adjacent areas to spread, but also cause patterns of circulation that are going to lead to updrafts of hot embers and dispersal of those on the landscape. That's going to happen in a large area when it burns, but a small area, you're not likely to get enough local heating to generate updrafts. Again, when we think about these patterns, human influences cannot be ignored. This is a map of Alaska, and it shows different fires that have been caused by natural and human causes. The human-caused fires mirror the road patterns in the transportation networks. So you take a look at different fires that are anthropogenic, and they're really following the roads. And along those roads and where human activity is, that's where you're going to get the most anthropogenic fires. Here are where most of the lightning fires occurs. And you can see that these roads serve as a point of initiation for fires, but also often they're a point where fires can stop. So you can have interactions between a natural disturbance regime and an anthropogenic disturbance regime. Among these human impacts, when we start to ask why there's different disturbances associated with human society, then we end up having to incorporate socioeconomic issues to understanding the patterns of disturbances on the landscape. So, for example, in agricultural areas, one of the factors that affects the patch types, their size, their shape, their extent, has to do with whether we have large holdings or small holdings. And that's a socioeconomic issue. This is a satellite photo of northern Argentina, just north of the city of Cordoba. And what this illustrates is differences in the way that socioeconomic issues affect the patterns of disturbance in land use on a landscape. To the right, to the east, we have the plains, and to the west, we have uplands. Now that's a topographic difference, there's a landform difference, and this line represents it too. But there's also differences in how lands are used in each of these areas. The black represents native vegetation, gray tend to be grazing lands, and white are under more intensive agriculture. And you can see that there's a difference in distribution of the three types, but also in the patterns that are being exhibited in the plains versus the uplands. A lot of this has to do with the types of landowners and the size of the corporations, for example, that are going to own the land and the decisions that they make. In the plains, you can have mechanized agriculture, and that leads to a different set of decisions than in the uplands. Here, you have much larger land holdings. Here, smaller landownings with small farm operations that are generating the decision making based on agriculture, grazing, or keeping areas intact. This is a true color image, also remote sensing. Here's Cordoba down in the south, and here's a dividing line between the plains and the upland. And you can get a better idea of what that pattern looks like. And there's decisions that are being made at a number of scales, both at a small scale, but also at a larger scale, that determine the size of these patches and their arrangement. Whether it's under agriculture or not, whether it's being grazed or under crops, and then the size of the individual patches. Similar decisions are being made here, but there's different socioeconomic conditions that are leading to a difference in the pattern of utilization on the landscape. Some of that has to do with topography and landform, but it also has to do with the decision-making processes that corporations, for example, might use, or larger landowners, as opposed to individual small farmers. So, in order to understand at the broadest scale disturbance, land use, ecosystem processes, we have to incorporate socioeconomic feedbacks in the systems that are being used to make those decisions.